On example number 3, we are dealing with denominators. So if you have a variable which is on the denominator, now the variable that you're differentiating in terms of is on the denominator. I'm being specific here. Now, what do I mean by that, Jane? I mean the following. Let's say Elena is given something like this. Elena can be given f of x is equaling to 2 all over p plus 1 all over x. Now, there are two variables here in this equation. Okay? What are the variables that you see? There's a p and then there's a what? There's an x. Sure. Now, we are going to take the variable that we need to differentiate in terms of, we're going to take it to the numerator. We can't differentiate unless the variable that we're differentiating in terms of is on the numerator. What does that mean? It means this one here, because it doesn't have an x, this whole thing here, I don't have to take the p upwards. The p shouldn't go upwards. It's a variable again. But because I'm not differentiating in terms of p, let me do this. Let's say they say determine f prime of x. If they say determine f prime of x, what they mean is that you can't differentiate this thing here. You first have to come and take this one here. This one here, you are going to take it to the what? To the numerator. So that's what we mean when we say which we are going to take the variable that we're going to be differentiating in terms of into the numerator. Now, with that a little bit of understanding, let's look at the following. What do we have here? We have f of x. Okay? We are differentiating in terms of what they say determine f prime of x. Okay? Meaning we're differentiating in terms of what? Of x. What does that imply? It implies which you come and check with, okay, here you have x, is on the denominator. Okay? What you're going to do with this x, you are going to take it to the numerator first so that you can differentiate. So what are you going to have here? You are going to have f of x being written in another way. It's going to be written as 1 all over 2. The 2 is not going anywhere. It's not a variable. Okay? It's not even if it was another variable, we're not going to take it up because it's not a variable that we're differentiating in terms of. Now, what's going to happen to this 3 here? This one here is going to go here, and then we're going to have x to the power minus 3. Now, what's changing? Not the x itself. The x is positive. The exponent is going to become what? Negative. Now that the exponent, that the variable that we're differentiating in terms of it's on the numerator, then we can differentiate. Then I can have f prime of x. Now, our laws of differentiation have been changed. We're going to say minus 3 multiplied by 1 over 2 again. Then we're going to get minus 3 all over 2. Then we're going to have x minus 3 minus 1. Okay? Minus 3 minus 1. You remember the minus 1 from the laws of differentiation. Then we're going to have minus 3 all over 2 x to the power minus 4. And then if you want to be fancy, remember you can always take the exponent into the denominator again. Okay? If you take it back to the denominator, what are you going to have? You're going to have minus 3 all over 2 x to the power of 4. What did I do, man? I took the exponent, which is negative. Okay? I took it down to the denominator and then became what? Positive. So what is it that we're going to get a marks for here? We're going to get a mark for taking the exponent to the numerator. Yeah? Taking the variable that we're differentiating in terms of to the numerator. That's 1 mark. And then we're also going to get another mark for differentiating this thing. And then you are done.